Mapping diagram, just to recall to your memory, when you do a mapping diagram, you have two sections here. One represents the domain, one represents the range. You need to label it, your domain and your range, so that I know that you know. You're going to list your x values, least to greatest, in your domain. So you're going to say over here, this goes from -2, -1. What do I have? 3 and 4. My range goes 1, 2, 4, 7, 8. And then I just draw a line. My 3 goes to my 2. My 4 goes to my 7. 3 goes to 1. -2 goes to 4. And -1 goes to 8. Is this a function? No, my 3 is going to two different y values. So this guy is not a function. If I had had a 1-to-1 from my domain to my range, it would have been a function. It does not matter if two of your domains go to the same range. It only matters that each domain has only one answer. Vertical line test, even easier. Is this a function? Well, no, it is not based on the vertical line test, because if I draw a vertical line, I cross it twice. So that is basic your mapping, and are these functions? Questions, pretty much, is how that's going to go. Then we get into domains. Identify the domain, and they want it in set notation and in interval notation. Remember, set notation is the little squiggly lines, x such that x equals or does not equal. Interval is either this or this, depending on if it's inclusive or not. So really, I don't care what happens in my numerator here. This is different than the discontinuity questions. This is strictly asking you to tell me about the domain. I could actually combine all of these into one and say, give me the domain and then tell me where it's discontinuous and what type of discontinuity I have, right? Because basically the process is the same, except when you're just talking about domain, you really don't care about the numerator at all. If I was talking about points of discontinuity and what type, you would need the numerator simply to decide if it can cancel or not, right? But for something like this, I don't care about the numerator at all. I only care about the denominator. And so I'm going to say, in this case, where is the denominator 0? That's where any of my problems are in my domain. And so I would factor this guy. Take out your x first. You have x squared plus x minus 6. You can keep factoring him. Factors of 6 that subtract to give you 1. We're going to have a plus 3 and a minus 2. That is my factoring there. And then I'm going to say what makes each of these 0, because zeros in the denominator are my problems. Well, for this guy, 0 makes him 0. For this one, -3 would make him 0. And for this one, +2 would make him 0. Those are all the problems with my domain. And so then I need to actually write those out. In set notation, it would be your bracket like this. And x such that x does not equal these three things, -3, 0, and 2. In interval notation, I would just go from -infinity to +infinity, and I would to create little breaks in that where I have those breaks. So I would start at -infinity, which is always open, and I would go to my first one, -3. It does not include -3, so I need an open bracket there. Union with from -3 to the next guy, union with from 0 to the next guy, union with from 2 to infinity. And so I'm simply breaking up my domain into those sections. It includes every single number in between those breaks, pretty much, right? And that's what I'm saying in two different ways. So for something like this, it would be easier to do set notation, right? Versus interval notation. For your square roots, which are on the next page, those are actually interval notations are usually easier for those, right? Because I can just go from my number to infinity or to -infinity. So if you do have a square root, you're basically going to say what's inside my root has to be greater than or equal to 0. What's outside my root doesn't affect anything, by the way. Only what's inside the root affects your domain for those next questions. All right. Slope-intercept form. These words should bring to your mind a specific equation. That equation is y equals mx plus b. All right. But because I don't have my m or my b, I've got to find my slope, and I really need to then work out my slope-intercept using usually point slope is what we typically use. So the first thing I need to do is find my slope, which is my m of that equation, which is y2 minus y1 over x2 minus x1. So you do need to know your slope equation. Subtract your y's over the subtraction of your x's, all right? And you do need to work it out. -3 minus a -2 is -1. -2 minus 3 is -5. Negative over negative is a positive. So positive 1/5 is my slope. Positive 1/5 is my slope. I'm not done yet. They want the whole equation. I just found the m piece of it. I need to find the y piece of it, right? Typically you use point slope to do this. Either of these will work. I'm just going to use the first one. So from here, you probably want to use your point slope. And just a reminder, your point slope equation is y minus y1 equals m x minus x1. You could plug it back into your slope-intercept and just solve for b if you want to, and then plug everything back in. This will just get you straight to it. So I have y minus my y1 equals m that I just figured out, x minus my x1. And then to get it in slope-intercept, just algebra here, right? So we're just going to move the numbers over. So this is y plus 2. Distribute your 1/5. So we have 1/5 x minus 3/5. Subtract that 2 over. 2 over 1 is 10 over 5, right? So y equals 1/5 x minus 13/5. And that is my answer. So I am done there. Oh, I don't want that guy. All right, any questions on that one? The graph as well as the slope. When you have it in standard form, so y equals mx plus b, you kind of are handed some of these, but when it's in standard form, you really have to just either plug in a 0 or remember that it's going to 0 out and divide. So my x-intercept is what happens when I 0 out the y piece of it. If I 0 out the y piece of it, I just get x equals -2. So my x-intercept is going to be -2, 0. My y-intercept is what happens when I 0 out the x. Well, if I 0 out the x piece, I get -2y equals -2. Y equals 1. So my y-intercept is going to be 0, 1. My slope is always going to be my -a. So if this is ax plus by equals c, my x-intercept is always going to be c over a. My y-intercept is always going to be c over b. That's how it's always going to work out. And my slope is always going to be -a over b. Because if I move that over and put it in slope-intercept form, it's going to negate the a and divide by the b, right? And so in this case, my slope is going to be -1 over -2, which is just 1/2. That is my slope. And so I've really solved for the first three pieces here: x-intercept, y-intercept, and slope. And when you graph it, you can literally put your x-intercept on the x-axis, your y-intercept on the y-axis, and then you just connect the dots. So for this particular graph, my x-intercept, that's right here. I go to -2 on the x-axis. My y-intercept was +1. I go to +1 on the y-axis, and then I just connect the dots, and that is my line. That is the graph of my line. Parallel lines have the same slope. Perpendicular lines are negative reciprocals. So negate and flip your slope, all right? For this one, you are still going to use your point slope. So you are going to use your y minus y1 equals mx minus x1. They hand you your x1 and your y1. So they hand you your x1, they hand you your y1. They've also given you a reference line parallel to this line, perpendicular to that line. And so they technically have given you your m as well. If it is parallel, your m is going to be the same. So your slope is going to be whatever your m is, in this case 6. All right? For perpendicular, they've also given you your x1 and your y1. But your slope, you're going to do a couple of things. You're going to flip him. So instead of 1/3 for a perpendicular line, you will flip it. It will be 3. And instead of negative, it will be positive. So whatever it was, you're going to negate it and you're going to flip it for perpendicular. And then the process is the same. You are then going to plug it back into this guy and get the y by itself. So like for this one, you would say y minus my y1 equals this m, 6, x minus my x1. And of course, you will want to simplify this as much as possible. So I'm going to say y plus 3, this is plus as well, equals 6x plus 6, subtract my 3 over, y equals 6x plus 3. That's my parallel line. I would do the same thing for perpendicular. Y minus my y1 equals this m, this perpendicular m, 3x minus my x1. You'll notice that I am not using anything else from those reference lines. I don't care about that -5. I do not care about that -2. I only care about the slope of that reference line. All right? And then I'm going to continue. I'm going to distribute that 3. So I have y minus 3 equals 3x minus 3. I'm going to add that 3 over, which gives me y equals 3x plus 0, but you don't have to worry about the plus 0. And so that would be my mx plus b for that one. So you're using those for really all of your linear equations. You'll notice that you're using the same equations over and over and over. All right. All right. Here is the same process of when you did domain for me, okay? The only difference is for the first set, I'm handing you a number and saying, is it continuous at this specific point? And if it's not, what type of discontinuity, okay? So you have a couple types, or technically 3 types. So the first 2 typically deal with a rational function, meaning you have a denominator issue, okay? Somewhere the denominator is 0 for these 2. You have a point discontinuity and an infinite discontinuity. If the denominator is 0, it's going to be one of these 2 for a function like this, a rational function. And the way you decide is, can I cancel it out with something in the top? If I can cancel it out with something in the top, it is point. It's called removable. So if I can remove it or cancel it, it is point. Okay? If I cannot cancel it out, it creates an asymptote and it is an infinite discontinuity. It goes off to infinity. So this is non-removable. Non-removable, or I cannot cancel. Cannot cancel. All right? I have handed you 2 points here. All right? So what I'm going to do here is I am going to just factor this denominator. The numerator here is already factored as much as it can be. So I'm going to factor this. The only thing I can do is take out an x. X, and then x minus 4. The first thing I have to decide is, do those 2 points cause a problem, right? Well, does 0 cause a problem? Yes, because if I plug a 0 in, this guy is 0, and my denominator is 0. Does 4 cause a problem? Yes, 4 does cause a problem, because if I plug in a 4 there, that is 0. So my function looks like this. I have negative x over x, x minus 4. We know both of those are discontinuities. We just need to figure out what type. All right? So for the 0, this is my problem with my 0. Can I cancel it? Well, yes, actually, I could cancel my problem with this numerator. I canceled the 0. What type of discontinuity is it? Point. So I have point at x equals 0. The 4 caused a problem here. Can I cancel a 4? No, I cannot. That is infinite. At x equals 4. And that would be my answer. This is my answer for this. All right. Now the next one I don't give you. I just say, is it continuous? So the first question is it continuous? That's a yes or no question. You're going to determine if it's continuous. All right. If it's continuous, you are going to write the word continuous and you are going to move on to the next question because you are done. But if it is discontinuous, I say classify it. By that I mean I want point infinite, or in this case, you may also have a jump. And so this is the most common type of jump. So you're going to look for a piecewise function. Now, I will say there are cases where piecewise are point. All right? Piecewise that are point will actually pull out a point. And they'll say, for everything not equal to 4, use this parabola. And when it's equal to 4, here's what you're going to use. That's a point. They legit pulled out a point and said, for everything except this point, use this function, all right? But for something that looks like this, they've given you 2 separate domains, less than or equal to 4 and greater than 4, all right? You still have to decide, is this continuous? The way you decide if it's continuous for something like this is you plug that 4 into both pieces. If it's the same number, it's continuous. It's going to come to that piece. It may change, and it may look like a line here instead of a parabola, but it's going to be continuous. If they equal 2 separate things, then you're going to have a piece of a function, and then it's going to jump, and you're going to have a piece of another function. And that will be a jump discontinuity. But you still have to determine whether it's continuous or not. So I'm going to plug it in here. 2 times 4 minus 8. What do I get there? I get 0. I'm going to plug it into the bottom. Negative 4 plus 7. What do I get? 3. That means this little function's trucking along on a line. That's 2x minus 8. It's a linear equation. It's going to get all the way to 4. And then at 4, it's going to be 0. Right? But after 4, it's going to jump to this new linear equation. Right? And at this new linear equation, it's going to be at 3, open circle. And then it's going to be a line, technically a line. So and from your perspective, it would have been a positive slope. Then it's going to jump from 0, open circle, and then it's going to be going down, a new line. This is a jump discontinuity. So you would tell me this is a jump at the point x equals 4. So when you get to 4, on the x-axis, this particular function will jump. It will jump to a new function. And so when we get to graphing those piecewise functions, that's what you'll start seeing. You'll start seeing this regular function. Oh, we're going to jump. We're going to be a new function. We're going to jump. We're going to be a new function. All right.